right, let me log out here so that I can show you exactly. We'll be seeing the same thing. Go to our D2L page. In the news, you'll see the blue box. It has a link to follow to register account. If you just go to lucidchart.com and register without following this link, it doesn't tie it into our class. If you do it this way, it ties into our class and you get a full account with no limits on it. Otherwise, you get a trial account. So click on that link. Don't type in a username or password over here. Come over here and create a account for you. So please include as part of your name 1113B, since that's what I call this class, since this is the second session that I have. Monday, Wednesday being A, Tuesday, Thursday being B. And then put your name, you know. George Orwell, whatever. Fill in an email address. It can be your Rose email address, just something you have to remember. Fill in a password. It could be your Rose password, something as long as you remember it.
Mr. Thompson?
Yes, sir.
On the D2L, it says there should be CIT1113A.
You're right. I need to correct that so it says 113B. I copied the notice and I did not fix that. Let me fix that right now.
So
Yeah. Okay, so if you just came in, what we're doing, go to D2L, look for this blue box in our news, follow that link, register a new account, and tack on CIT113B to your name so I know that you're part of this class.
Doesn't matter where.
Nah, I put mine in front of it, it didn't matter. Okay. Now, unlike the other one, you don't have to then go back and add me to teacher. So it's not like coding back where there's an additional step. Once you register, you're good. Alrighty. So let's think about a program that we're going to flowchart. Let's just write a little bitty dummy program here in Python. New file. Okay, what am I going to do? I'm going to ask them for their name. Print, what is your name? You don't have to type this program in. This is just going to be for us to flowchart. Name is equal to input. If name is equal to Joe, colon, because every indented block has to start with a colon, print, hey Joe, what do you know? Else, colon, print, you lie. Your name is Joe. Okay, that's kind of stupid anyways. But it'll prove the point. And then lastly, after all that, we're going to print done. Pretty easy program. You see the logic. So, looking at this, how many boxes are we going to need? We're going to need a box for printing. We're going to need a box for input. We're not doing any conversion, so that's good. We're going to have an if block. So that's 3 boxes. We're going to have a print statement. That's 4. We're going to have another print statement. That's 5. We're going to have a final print statement. That's 6. Now, input and output is all done with the same symbol, the tilted parallelogram, the leaning rectangle. Alrighty. You need to go to D2L and follow the link that's posted in D2L in the blue box and create yourself a lucid chart account. That's just about what we're going to do. And we are taping. Yippee. Okay. So, this is the program I want to flowchart. I'm just going to kind of knock it over here. Hopefully you're at this point where you can just click on the plus document sign, create a blank document. It says loading at the bottom. It looks like you're supposed to click there, but you're not. Now every flowchart, got a hand raised?
yeah, my lucid chart isn't letting me log in. Is it okay if I just draw a piece of paper or something?
I want you to be able to use lucid chart, so let's fix.
Or would Visio be okay?
Yeah, you can use Visio. Okay. Yeah, if you can't get lucid chart going, just open Visio. You know, go to the start menu, type Visio, you're good to go. All right, so every flowchart is going to start with a little symbol up here, a little pill-shaped symbol. It's either going to say start or stop, or it's going to have a function name because you're defining a function and a return statement. But this doesn't have any function, so we're just going to say start. I'm going to make the text kind of big to make it easier for y'all to read. You don't need to do that. All right, now if I move my cursor here, there's more than one way to do this, but watch. If I move my cursor here and touch this little circle underneath the pill, I can drag a line, and then I can pick a new shape. In this case, the shape I want is the parallelogram, the tilted rectangle. If that doesn't work for you, you can always do it like this. Just go and grab the parallelogram from the little box over here and drag it out. Either one works, but then you're going to have to draw a line from one to the other. Okay, so this is going to say print enter name. If you want to put a carriage return in it so to make it prettier, position where you want your carriage return and then hit Control Enter, because if you just hit Enter, it saves the text like that and you can't do anything with it. But I want a carriage return, in my case, between the words enter and name so that it'll look prettier. So I'm going to put it before the word name and hit Control Enter, and then now it's on 2 lines. So Control Enter is how you go to a second line. And again, I'm going to increase the size of mine. You don't need to do that on yours. You can also resize the boxes to try to get more stuff on the screen at the same time. I'm going to resize this one a little bit. On mine, I'm putting a premium on saving space so that I don't have to scroll down, up and down as much. But yours doesn't have to be this squished. Okay, so for output, we use that shape. For input, we also are going to use that shape. Yeah, there's another shape over here that we could use called manual input. But more traditionally, you just use this one. Draw a line between the two, and this one is going to say input name. Notice that these are not actual Python syntax. You know, this is not actual code. This is just representative of code logic, and you could give this to a different programmer in a different language and he'd be able to write this. A different programmer in a different language doesn't need to see exact Python syntax. He doesn't need to see the equal sign and the input and the parentheses and all that. So we're just kind of wording it generally. Okay, now we have their name. Now we need to decide if it's equal to Joe or not. I'm going to give myself some space here to go to the left and the right. So I grabbed all 3 objects by clicking and dragging, drawing a rectangle around them, and then pulling it like that. And the reason I'm going to do that is because I'm going to use a decision block, and it's going to go to the left and then to the right. Okay, so the decision block is the diamond, the rhombus, whatever we want to call it. I'm just going to call it a diamond. And that's going to say if name equals Joe. And I'm going to hit Control Enter to put the word Joe on the next line. Now, strict flowcharting rules say you leave off the word if. But we're not doing strict flowcharting rules. We're doing flowcharts that make the most sense to us. So I'm putting the word if there. Because you can also use that symbol for a when statement or a for statement. And so I like to differentiate. Flowcharts precede programming languages. So there's not a one-to-one correspondence between language statements and flowchart blocks. Okay, so if the name was Joe, then what did we do? We printed out, hey Joe. Else we're going to print out, you lie. So I'm going to make one block go to the right, and I typically make my true block or my yes block go to the right. So I'm going to make that go over here, and another print statement is going to be another parallelogram. And so we're going to print, hey Joe. Now for my flowchart, I'd really like this yes line to mount on the top rather than connect on the side. So I'm going to see if I can grab the arrowhead. So I'm going to select the line by clicking on the word yes, grabbing the arrowhead and pulling it over here. And if that works, great. And if it doesn't, well, okay. Cool. Now the flowchart we're drawing has curvy lines. That's okay, but you can then go back and change the curvy lines to straight lines. The way you do that is you click on the line, and then there's this little curve symbol next to the pencil, which represents color, and you can choose a different kind of line, like a right angle line or a straight diagonal line. I'm going to leave it a curve. But later on, you may see me change them to straight lines. Okay. If that's not true, we need to print something else. And so I'm going to draw another box that comes over here, but instead of it saying no, I'm going to make it say else. And the reason I'm going to do that is because the code actually is after an else statement. So here again, I'm veering off from normal flowchart terminology. The ways that I've differed is I actually put the word if in my decision block. You can leave that off. And some flowcharting regimens want you to put true on that side and false on that side. I'm putting yes on this side and else on this side to make it match our code. Okay, and in this case, I'm also going to print something. I'm going to print you lie. I'm going to make my text a little bit bigger, move some things around. You don't need to be so picky. There are commands for arranging things, in a straight line up and down. All right. After our if statement, things need to hook back up together. You can use either a little bitty circle like that, but that's kind of hard to deal with, so I'm just going to go to the next line, which was a print statement. The last thing it did after it printed either hey Joe or you lie was to print done. So one more print box, print done, and both of these need to go to that. And again, it doesn't really matter if you hook the tops or the bottoms up or if it goes into the sides or whatever. Flowcharting is kind of an art, and by that I mean you can make it look how you want it to, just like when you grab a crayon and draw a picture, you can make it look how you want it to. There are just certain things that I want you to do, and one of the certain things is that I want you to put input and output in the parallelograms. I want you to perform calculations in the square rectangles, not square, but the rectangles that aren't tilted. I want you to put your if statements in the decision blocks. I want you to use the word if. All right. Lastly, I'm going to draw one more line, and it's going to say stop. So it's going to go to a pill shape and say stop. All right, I'm going to zoom away and see if it all fits on one page. Okay, I know that y'all in the back can't quite see that. You probably can. Start, print enter name, input name. If name equals Joe, yeah, that's cool. Yes, print hey Joe. If else, print you lie. Have them join back together and do print done. Then stop. Okay, now we need to save our document so you can load it up again. If you're at the point where you can save it, do File, Save As, and give it a name. Like CIT1113B first flowchart. And then you want to save it to disk. The way you save it to disk is not with the Save As command, like if it was a desktop application, but to do File, Print, and if you're using Visio, just upload the Visio document. File, Print, and it will create a PDF. Just call it first flowchart, .pdf and save it. Then you get a PDF that you can upload to the Dropbox I'm going to create. All right, there's our themes over here that you could use. If you want to play with the themes, grab and highlight everything, and then come over to these three little boxes. Pull down, and you see a whole bunch of boxes. You know, you can choose gray with straight, white with straight lines. There, look, miraculously my curves became right angles. If you like colors, you can do that. I wish there were colors with straight lines that were, anyways. I kind of like that one. Or maybe I like that one. Okay, there we go. You don't have to change themes, obviously. That's just, you know, make it look pretty. Okay, that's a flowchart. I want to show you what an if statement looks like without an else. I'm just going to copy all of this stuff right here. So I'm going to click and drag over my entire shape. And by the way I'm zooming in and out is with the control key. I hold control key and then spin the mouse with the control key down and it zooms in and out. That's far easier than trying to use any magnifying glass you may see on here. Now you don't have to do this, but I'm going to copy my entire thing with Control C. Then I'm going to paste it with Control V, and I'm going to move it like maybe to a second page or something. I'm just going to drag it over here. Now I have 2 pages. It automatically extends it. So, you know, if your diagram goes off the page, that's fine. It's going to make it larger. Okay, now an else statement without, an if statement without an else looks like this. I'm just going to delete all of that stuff and then draw a line going like that. There we go. It doesn't have the word else. Don't modify your document to look like this. I just want you to see it. Maybe we'll draw another one later. So this says if name is equal to Joe, print hey Joe. But if that's not true, there's no else. It just falls straight through. So if I was going to modify my code to match, it would look like this. It wouldn't have an else. You see what I mean? This is the second match. Input name, or print name. Input name. If name is equal to Joe, print hey Joe. But there's no else statement, so just go straight through and don't make the word say else, just let it say no. You can even delete the word if you wanted to. And then print done, and then stop. So 2 ways of doing an else. 2 ways of doing an if. If you do an if and it has an else, go to the left and the right. If you do an if without an else, go to the left. Go to the right, but don't go to the left, just go straight down. Hope that makes sense. Anybody need any help saving this, publishing it? That was good. All right, so we just need to do save, unless you want to is it full name like CIT 113B space first flowchart? I haven't got the Dropbox ready, so if you're going to look for the Dropbox, it's not quite there yet. Where is this save? Okay. Cool deal. Now we need to save it to disk. So we do that arrow pointing down. Seems to be the way to save it to disk. Got to do a file print. Just generate a file. Oh, it's really wanting me to print it.
Those 2 downloads.
Save as PDF. Okay, if it actually tries to print it, just a second, I'll show you how to download it again because I'm having to change the setting.
Would a screenshot be okay?
Screenshot would be okay, yeah. All right, we switched it to PDF. We did that by clicking change. We're not going to deal with that. sorry about that. Not everybody's is behaving the same way. Some people, when they do print, it's actually bringing up a print dialog. Here's how you save it to disk if you're not going to just do a screenshot. File, print. See, and it went straight to this. If you don't see this dialog, if it's trying to go to a printer, there's a button that says change. Click change and you can choose PDF, and then it'll behave just like mine is. I apologize for this not looking just like yours. Don't know what I have to do to change it to make it look different. Not seeing any way to fix that on mine. Okay, so like I said, if you want to save it to disk, choose File, Print. If it's not trying to save it as a PDF, if it's not trying to save it to disk, there'll be a change button. And then you can click change and change to save it to PDF. Does that help you? Who was asking for help saving it to disk? Do File. Have you saved it yet? Go, yeah, File, Save As. Are you using Visio or are you using a online program? Are you using Lucid Chart or? Oh, you're already in Acrobat. Okay, it's already saved. Wherever this document is, it's got a bad name, but you can go out and find it. You might be able to do a File, Save As. I don't know. Choose a different place to save it. If I call it CIT1113B space first flowchart. We all good? Yeah, everybody's is behaving a little bit differently, which always annoys me about computers, because the thing about computers is that they should behave the same, you know, and it should do the same thing every time. So it irks the holy heck out of me when it doesn't. Okay, so we've drawn our first flowchart, and now you know the tool to do so. If I ask you to draw a flowchart as a quiz or an exam or something, you don't have to do it on this. You just, grab a piece of paper and draw the flowchart. That's just as good. The problem with doing it on a piece of paper is everybody grabs a pen to do it. And then it's really hard to make changes. But that's because everybody likes pens rather than pencils. I can't stop you from doing it, but your flowchart's going to be messier. Okay, let's make a Dropbox for it. So there's our Dropbox, inbox I, in class I. Alrighty, I believe that we were completely done with that chapter that we've been working our way through. How to think like a computer scientist. I'm wanting to get back to head first programming, but we need to cover conditional logic and finish that off. So we've talked about a lot about functions. We're so over that. We're going to do conditionals. And I think we've talked about conditionals, right? We've talked about comparing with equal. Is that right? And less than and greater than and stuff like that. So all of these are expressions that evaluate to true or false. And you could either store the results of that expression in a Boolean variable, or you can use an if statement. If x is equal to y. Logical operators are the and the or and the not. That means that both sides of the expression have to be true if you use and. If you use or, then either one side or the other side of the expression need to be true. If not, both. So I'm going to delete our code here. We don't really need this. Well, I may want to put that on our chart. Okay, so for example, I'm going to make a program, and I think I've done this before, that determines whether something is freezing or boiling. So, temperature. We could ask somebody for their temperature. Print, what is the temp? T is equal to input. Now normally in Python you just put this inside the input statement, so if I'm not flowcharting it, that's how I'm going to do it. I deleted the print statement, I moved that there. Now I have to convert it to a number, either a float or an int. What if they type a decimal? Well, let's make it a float then. Now I can use my if statement. If, I'm going to use parentheses, but they're not necessary in this language. They are in some. If t is greater than freezing and T is less than boiling, I'm using Fahrenheit now, then print is a liquid. Now I'm going to flip the logic so that it'll print is not a liquid. And to flip the logic, I'm going to check outside the range. This is checking within the range, and both conditions have to be true because of the and. If T is not greater than 32 and less than 212, it's not going to print that. It's going to skip that line. So flipping the logic, I have to flip that. I have to change that to its opposite, and I have to change that to the opposite. What's the opposite of T greater than 32? It's not merely T less than 32, because what if it was 32?
32.
It's T less than equal to 32. And when you flip logic, you change ands to ors, and you change ors to and. So there we go. Or if T is greater than or equal to 212, then we will print is not a liquid. So I hope you see the difference between an and an or. Or means only one side has to be true. If they're both true, it's still good. But only one of them have to be true for the result to be true. And means that absolutely both sides have to be true before this expression is true. So if I type in 72, is it going to print is a liquid or is it going to print not a liquid? Well, you already know that 72 degrees is a liquid, but let's check it out. T greater than 32. Well, is 70 greater than 32?
Yeah.
Yeah. Is 70 less than 212?
Yes.
Okay, so it's going to print as a liquid. Now let's see if the second one is going to print not a liquid. Is 70 less than or equal to 32? No, but we have to keep going. Is 70 greater than or 212? No. Okay. So we inverted this. We flipped the logic of it. And to flip a logic, use something called DeMorgans Law, which is where you change these expressions, you flip those expressions, so T greater than 32 becomes T less than or equal to, and then you change ands to ors or ors to ands. So this checks within a range using and this checks outside of a range using or. And then not just flips it. We could use not T is greater than 32 here. But to me that makes it harder to read. You know, if not T is greater than 32 or not T less than 212. That's valid code, but to me that's harder to read. What the not does is whatever follows, if that was true, then that turns it to a false. Okay, so let's say that temperature is equal to 70 again. We come here. Is 70 greater than 32? Yes, it is, but then the not makes it a false. Is 70 less than 212? Yes, it is. But the not here flips it to a false, and so we have false or false, so the result is false. I think nots make things harder to read. I use them sparingly, so I'm going to delete the nots. I guess I should actually test this out. All right, what is the temp? 90. It's a liquid. What is the temp? Negative 12. Below 0 is not a liquid because it's frozen. Okay, cool. Seems to be working. I'm going to try above 212 now. Run module. What is the temp? 400 degrees. It's not a liquid. Okay. So this logic works. I'm pretty sure y'all get the idea behind and or now, especially because we did it also at the beginning of the class when we were anding value zeros together. To check to see if something is evenly divisible by 2, you can take the modulus of it. So if we wanted to see if the temperature was even, an even number of degrees, we could do this. If T percent 2 is equal to 0, then we could print T is an even value, meaning it's evenly divisible by 2. Why is that? Because that means remainder, you know. You divide something by 2, and if the answer is if it has no remainder, it's an even. If it has a remainder, it was an odd value. Like 4 divided by 2 is 2 with no remainder, so the remainder is 0, so that means it's an even value. If we wanted to flip the logic of that, there are so many different ways we could do it, but I would just use not equal. If T percent 2 is not equal to 0, then print T is an odd value. Okay, I'm going to stick my return statement there so it'll stop asking me for my name. Oh, fine. Take the return statement out. What is the temp? It's 90. It's a liquid and it's an even value. Run it again. What is the temp? It's 1001. That's an odd value. It's not a liquid and it's an even value. The reason for that is that 1001 modulus 2, well, 1001 divided by 2 is 500 with a remainder of 1. So not equals 0. That whole thing evaluated to true. It's a Boolean expression. You can store the results of one of these Boolean calculations in a variable and then check it. I could do this, like even, is even. Y'all have heard that phrase, you know, I can't even. So there's a joke, you know. Why do teenage girls always travel in odd numbers? Because they can't even. All right, sorry. Not one person left, I'm crushed. Okay, so if is even, that looks like if 7. If is even is equal to T percent 2 equals 0. And then I could just do if is even. Print T is an even value. You see what I'm doing here? Here we're doing that Boolean calculation, but instead of it being inside an if, we're storing it in a variable first, in a Bool variable first. And then we're doing our if based on that Boolean variable. Hope that makes sense. If you were going to use this calculation over and over, or if this was a really complex calculation, it's reasonable to perform the calculation first, store it in a variable, and then do your if on that variable. Otherwise, just put it inside the parentheses of the if statement like that. There's no advantage to doing that in this case. It's not like it's going to run faster or slower or anything like that. Just whichever is easier for you to read. Yes, sir.
Not really understanding the logic on that.
Which part?
The equals and then the parentheses with the comparison inside of it.
Okay, yeah, that's kind of an abstract concept. Variables can be strings, they can be ints, they can be floats, but there's a fourth data type called Boolean. And that Boolean can either be a true or a false.
Okay.
So what happens is everything inside the parentheses evaluates.
So if that statement's true.
If this is true, then the value true gets stored there. And this is a shortcut for saying is even equal true, like that. You can always leave off the equals true, but you know, if you wanted to write that to make absolutely sure it was clear, you can do that. Very good question. Does that make more sense? Okay, cool. And now we could do the same thing. Is odd is equal to T percent 2 not equal to 0. And then if is odd is equal to true. Print T is an odd value. It's the same logic we did before. It's just storing the result of that calculation in a variable and then doing our if statement based on that variable. And like I said, if you're comparing something equal to true, you can just remove that part of it because that is the same as doing that. So truth table. We did this way back. When? If you have A and B, and then you have the expression A and B, both sides have to be true for the result to be true. So the only result that's true is when A is true and B is true. Then the result will be true. The rest of them are false because both sides have to be true. False and false. False and false is false. False and true is false. True and false is false. True and true is true. Or you can do an or statement. A or B. A or B means that even if only one side is true, the expression is true. So false or false, well, neither one are true, right? So the result is true. But what about false or true? Well, at least one side's true, so we're good to go. The result is true. True or false, well, one side is true, we're good, is equal to true. And then if they're both true, wow, so much the better. And then there's not. You know, not just says that if you're given a false, not turns it into a true. If you're given a true, not turns it into a false. I don't know about this. Conditional execution. We've seen this already. If x%2 is equal to 0, print is even. Else print is odd. And a cute little trivia here. Did you know that 2 is the only even number that is prime? Well, we know now. Did you know that multiplying two odd numbers always gives an odd result? Very true. And if you multiply something by an even number, you get an even result. Okay. So here's how they're doing it. How is this different from the flowchart I was showing you? It differs in two ways. Anybody spotting the differences? I tried to point them out as I was drawing it. Is there anything different about the diamond block here? I put the word if there, right? Y'all remember that? That's the difference. And the other difference, well, besides the fact that this says true, that's just because that's what the drawing program defaulted to, is I put else here. And the reason I put else here is to remind myself when I was coding it that that code's going to go under an else block. Doesn't matter. Even if it was said false there, you still have to put an else there in order to get it to work. I just like adding the word else on my flowcharts. You can do it either way. You can make it say yes, no, yes, else, true, false. All those are good flowcharts. You can leave off the else clause, and I show you that. I showed that to you. If condition is true, then execute some statements. There is no else, so we fall straight through. That's like this. If x is less than 0, if x is less than 0, print it's a negative number. There is no else clause, so then there's no else statement down here, and we just print the square root of x as whatever. Change conditionals. You can chain them together so that you can do if something, else if something, else if something, else. You know, and the classic example of that is asking somebody for their grade. You know, G, grade is equal to input. What is your numeric score? Then we have to turn it to a value, either an int or a float. I'm going to turn it into a float in case they type in 90.1. All right, now I'm going to use if, else, if statements to print out their letter score. If grade is greater than or equal to 90, colon, print, that's an A. Elif, that stands for else if. Some languages you actually use the words else if. Python uses elif. Elif colon, wait, no, not colon. Elif grade is greater than or equal to 80, colon, print, that's a B. Let's tack on another one. Let's tack on C. Elif grade is greater than or equal to 70, colon, print, that's a C. And now according to this grading scale, you either have to make an A, B, or C, or you fail. So our last thing is going to be an else to handle all other cases. Print, oops, F. There we go. So this is called a chained conditional. That's a silly name for it, or a complicated name. It's just a series of if, else, if statements. This forms a mutually exclusive list of possibilities. Only one of these things is going to be true. We're either going to print that's an A, or we're going to print that's a B, or we're going to print that's a C, or we're going to print that's an F. Flowcharting those is a little bit of a bear. So get grade. If grade is greater than 90. Then we're going to print A. Else, and I'm actually going to, put a diamond here that says elif grade is greater than or equal to 80. If that's true, we come over here and we print something. If that's not true, we have another else if to do. Elif grade is greater than or equal to 70. Then print C. And then the last condition is that they failed. So this one is just going to say else. I need the word else here instead of the word no, which is what I had previously. Alrighty, and if that's true, we print F.
Wouldn't that elif be a dot too? Or something?
Let me finish the drawing and then we'll answer that question, okay? Alright, and then they all need to hook back up somewhere. I'm just going to put a little thing down here at the bottom. This is called a connector. A connector is something you use to hook lines up. It's not a statement in and of itself. It's just a place to hook lines up. Come on. There we go. But I have to hook all my lines up to that. All my is-self says go here. So print C goes to there. Print D goes to there. And you can see that it's kind of looking ugly. Come on, guys. Yeah, I like that. And then lastly, this print statement needs to go there too. And then we would print, end of program or whatever. Dealing with these little circles is kind of a pain. You have to zoom way in order to move them or hook them up. Okay. Now, does that make sense? This actually matches our program. We get their grade. If the grade is greater than 90, we print, you made an A, and it goes all the way to the bottom. skips all the other if else's. If that's not true, we do elif grade is greater than 80. We print B, and then it skips all the elif and the else's and goes down here. If none of those were true, else if grade is greater than 70, it prints C. It goes all the way down here. And then if none of these are true, then it prints an F and it goes down there. Okay, could you repeat your question now?
Oh, I was gonna say, why is that 70 LF the square one instead of a diamond?
Thanks. Very good point. I used the wrong shape there. That should be a diamond. All right. That's about as good as I can make it. You can see that the if-else if, the cascading ifs, they call it a conditional chain. I think that's what they just called it. A change conditional is a series of if-else statements. If, elif, else. That's a change conditional. I don't know why they called it a change conditional. Other books call it an if cascade, because it kind of looks, if you draw it, like a waterfall. What do I mean by that? Well, go back to our flowchart and we'll, if you do it the other way, where this is the closest one and then this is the next farthest one and then this is the farthest one still, then it starts looking like a waterfall, you know, like that. But that made it look ugly, so I'm going to undo that. So now we understand elifs and elses, right? It's always a good idea, if you have a whole bunch of elifs, to put an else at the bottom, even if you think it'll never get there. It might. It might be an error condition if all that happens. So if you have like more than one, if you have an elif, put an else at the bottom, just to make it print, you know, error condition or whatever, if you were trying to handle every case. Now, if you're not, you know, if you're not going to print anything, if these 30 things are true, then you wouldn't need an else. Here's our version of the change conditional. They leave off the words if. I like the words if, so I would make this say if x is less than y, do that. Elif x is greater than y, do that. And then I would put the word else here instead of false. Nested conditionals. Nested conditionals are when you have if statements tucked away inside of other if statements. Let me give you an example of that in code. They call this change conditionals. So I'm going to add a comment here. Change conditionals using if, elif, else structure. Okay, now we're going to do another one. Nested conditionals, which I'm just going to call in this case a nested if. So we need two things. We're going to ask them whether they have a college degree and whether they are employed. So, degree is equal to input college graduate, yes, no. Then we're going to say employed, or job. Job is equal to input, are you employed? Yes, no. Now, based on that information, if both of those things are true, we want to print out that they get the special discount. So if degree is equal to yes, then we're going to have another if inside that. If job is equal to yes, then we're going to print, congrats, you get the discount. Now this is a cruel store because the people who aren't college graduates and who aren't employed are the ones that need the discount. But, you know, we didn't make up these rules. Yeah, I just did actually. But this is what's known as a nested conditional. It's an if inside a conditional. And if you look at this, this is kind of the same thing as doing an and statement, isn't it? Because that one has to be true and that one has to be true before this happens. We could replace this nested conditional in this particular case with an and statement. And it would look like this. Sorry if I went too far down. Sometimes you can replace a nested if with an and. If degree is equal to yes, and job is equal to yes, print congrats. You get the discount. So this is kind of a rhetorical question, but which one do you like better? Do you like this, or do you like this?
All similar.
I think the and statement is easier. That's just my opinion. There may be times when you can't do it, and that's if you have if-else statements inside your if statements, like this. If degree is equal to yes, if that's all true, but you might want to print an error message, else print you must have a degree. And if this one's false, then we're going to print you must be employed. Now we can no longer duplicate this with an and. We could get real close to it. You must be employed. Okay, we could not duplicate that exactly with an and because we have three conditions here. This one happens if we are employed and we have a job. This one happens if we, I'm sorry, I messed that one up. This one happens if we have a degree and a job. This one happens if we have a degree and no job. This one happens if we don't have a degree. We can't quite duplicate that with this. If we wanted to, we could say you must have a job and have a degree, and that would pretty much cover it, you know, but we're not telling them exactly what's wrong. Like that. That's pretty close, isn't it? Maybe it's good enough. The logic is simpler. Certainly easier to flowchart this, and if it's easier to flowchart, it's easier to program, it's easier to look at. If you're going to flowchart nested conditionals with all sorts of else's like this, then it looks pretty ugly. Here's an example of what it looks like. If x is less than y, then print this. If that's not true, is x greater than y? Print this. Else print this, you know. So here we see some else's involved. If it's true, it goes that way. That's the else clause. And then there's a second if nested within the else. So here, if that's true, go that way. Else, do that. So nested conditionals are great, but, you know, see if you can simplify the logic. The return statement. We've already talked about the return statement, but you can use the return statement inside of an if block, but it can make the logic a little bit more confusing. Now, to use a return statement, I have to be inside of a function, so I'm going to define a function. Define example. And I'm going to take a variable called a. If a is equal to 0, colon, that's an error case. Print a must not be 0 for whatever reason. Like, what if we're going to use a to divide by? We don't want to divide by 0. We could return right there. Then we could continue the rest of our code. You know, b is equal to 10 divided by a. Print, you know, 10 divided by a equals B. That might actually work. And then we would need a call example. You know, we could pass in a value. If we pass in 1, it's not going to be the error case. If we pass in 0, it is the error case. So you can use return to bail out early. In this case, we didn't even have to use an else, right? Because we knew that we bailed out of the function completely at that point. So all of this code got executed. Only if this wasn't true. If you want to use else here, that's totally cool. You could do else, colon, and you could do that, you know. I think that that's cleaner looking, but it wasn't strictly necessary. Now, the problem with sticking return statements inside the middle of an if statement is that this function might be 20, 30, 40, 50, 100 lines long. And if you start hiding return statements in the middle of a function, it gets really difficult to understand how the function works. Whereas if your return statement is only at the bottom, quite often it's easier to understand. But this is a possible exception to that rule. My rule of thumb is generally only one way to return, out the bottom. But if you could do some error checking up at the top and return early before entering the rest of the code, that's an okay use for returning early, doing an early return. Because why even get into the mess of the code with ifs and elses and stuff like that if you can rule out a problem right away? I wonder if all this works at this point. I sure have a lot of code here. Okay, I always leave my colons off my elses. Just a habit from C and C++ and Java. I had to fix that. What is the temperature? The temperature is 90. What is your numeric score? I made an 81. That's a B. Am I a college graduate? Yes. Are you employed? No. You must be employed. You must have a degree and a job. Sorry. 10 divided by 1 is equal to 10. What is your name? I don't know. Joe. Hey Joe, what do you know? Okay, yay. The whole program did all of its silly comparisons. Logical opposites. What's the opposite of equal equal? Not equal. Exclamation mark equal. What's the opposite of not equal? Exclamation mark equal. Equal equal. What's the opposite of less than? I already mentioned this. It's greater than or equal to. The opposite of less than is not greater than. The opposite of less than is greater than or equal to, because you have to make sure you get that number. You know, if it's less than 100, that's true. But if it's greater than or equal to 100, you got to make sure you get that middle point, that midpoint. The opposite of less than equal is greater. The opposite of greater is less than equal. And the opposite of greater than equal is less than. Type conversion. Sometimes we need to convert types. So we've already talked about this. We've been using the int and the float number functions. You know, int and you pass in a string to turn it into a integer value, or float and you pass in a string and turns into a floating value. You can also convert directly from one to another. If you have some reason to want to change a float value to an int, you can do that. So for example, in my code, if for some reason I have a float number like way up here and then I want to turn that into an int, I could do that. I could say t is equal to int t. Now we've already got it as a float, but then I decided for some reason I wanted it as an int. There, that turned it into an int. So you can convert strings to ints or you can convert floats to ints. Similarly, you can convert strings to floats and then you can convert ints to floats. Now that's almost really singularly useless, but you could. Usually you use these to convert string to numbers so that you can do math on something the user typed in with an input statement. A turtle bar chart. This would be fun to type in, but I didn't. Here's a little program, a little function for drawing a turtle bar chart. It's kind of cool. We ought to make use out of this. So you call this function and you give it a number. What does it do? It turns left, it goes that number high. And then it turns right and it draws a line. It turns right, it draws a line, and then it turns left and it draws an itty-bitty line. Then you could call again with a different number, a larger number. It would turn left and go that height that you specified. Then turn right again, and go back like that. So that's pretty cool. Then they show something that I'd actually forgotten about, which is that you can use the turtles to add text to your drawing. That's kind of cool. You just put, where was that? Right. I'm going to tack that on just for total grins. Import turtle. T is equal to turtle dot capital turtle. T dot forward 200. T dot right. Hi, I'm a turtle. Okay. Then I'm going to run it. I just want to see that. Okay, and it printed hi. Itty bitty little text. You could probably make that larger. But that worked. Tell you what, as the last thing we do today, why don't we go ahead. I think I'm about to break this in a way that I shouldn't. Okay. Why don't we go ahead and type in that bar chart program? It's short. It'll be the last thing we do today. So I'm going to do new file. I'm going to save it as bar chart. Don't save it to your Python directory. Save it on the desktop or some other directory. We have to define a function called bar or drawbar or something like that. And it takes a value, and that value is how high it's going to draw. Why not X? Okay. Now I'm going to try to recreate this from memory rather than looking at the code. Firstly, we need a turtle up at the top. Import turtle. T is equal to turtle dot capital T turtle, parentheses in parentheses. Now if we draw a bar, we want to start going north. So I'm going to set the heading to north. Which is 90 degrees. And then I'm going to go up, forward. You can just type FD for forward. It saves some typing time. I'm going to go X number of pixels. Then I'm going to turn right, and whatever the width of my bar is supposed to be, I'm going to go that far. Like, I don't know, 50. And then no wait, it's a right angle. I'm supposed to go 90. My mistake. And then I'm going to go forward 50 pixels, just because I decided that each bar is going to be 50 wide. Now I need to turn right again and go down just as far as I went up earlier, so X number of pixels. Now I'm at the bottom of the chart, so I need to turn left so I can get ready to draw the next one. So I'm going to make a left 90-degree turn and then go forward just a few pixels. Alright, it's plausible that's even going to work. So I'm going to draw a bar that's 100 pixels tall. I'm going to draw a bar that's 200 pixels tall. Draw a bar that's 150. Bar that's 75. Bar that's 225, a bar that's 275. Might look good. Let's give it a shot. I may have syntax errors, so we may have to make some corrections. Yep. Heading takes one positional argument. What is it? Set heading. Yeah, it's set heading. Alright. So where it says heading is equal to 90, make it set heading. My mistake. Let's see if that's the only mistake. Yeah, that's looking pretty lousy. I did not succeed. Oh, that's Where I said t dot right x, it's supposed to be a right turn. So t dot right 90 and then t dot forward x. So where it said t dot right x, replace it with those two lines. All right, it's kind of working. I might want to make the bars skinnier, in which case instead of 50, I would use a smaller value, you know. Maybe I want to make filled bars, you know. There's all sorts of changes I can make to this. I feel like making some of those changes. So, I'm going to, nah, that's about enough. I want to go look at their code now. Yeah, see, their code is more complicated. But that'd be pretty cool to do. Let's tack that line on. Where it says t dot forward x, do t dot right space, quote space, space, plus strx. What this does is, since x is a number, it turns it into a string. That's the first time we've seen that function. But that's because the right function is wanting a string. I wonder how that's going to look. I need to make my bars narrower, so where it says 50, make that 30. Hey, that looks pretty cool. It turned out to be the right choice. We have 4 whole minutes. Let's go ahead and add the coloring aspect. To have a fill, let's do begin fill and end fill. So before we start drawing here, after we set our heading, even before or after the set heading, let's do it before. T dot begin fill. Parentheses in parentheses. Now there's 3 lines of code we need to add right here, above our t dot left 90 and our forward 10. So bear with me, we're going to tack on 3 lines here. These are going to be right here. We're going to turn right again and go forward 30 pixels. Wait, a right turn is 90. T dot right 90, T dot forward 30, which is the width of our bar. Now we can fill the bar. T dot end fill, parentheses, and change that, instead of T dot left 90, make it 180, because we're going that direction, we want to flip it and we want to go the other. So this is the end of the function now. These 5 lines. We just had 2 lines. We had the left 90 and the forward 10. We changed it to right 90, forward 30, end fill, left 180, forward 10. I'm going to see if this works and then I'll be right there. Not quite, huh? Admirable effort. Yeah, after we fill it, we need to go the width of the bar and 10 more. So make that 30 plus 10. Last line needs to be 30 plus 10. Hey, and that's pretty dang cool in my opinion. Yes, sir. Oh, you got it? Okay.
Well, ours basically gonna say the same thing.
Okay, yeah, thanks. I should have acknowledge you and let you correct my mistake rather than ignore you. My apologies. Okay, so what could we use this for? After we start dealing with lists, you know, we could make a list of monthly rainfalls, you know, and print the rainfall for each month. Or we could print, you know, the frequency of each letter in a body of text. So you typed in a paragraph of text from a book, and then it would print the number of A's and the number of B's and the number of C's or something like that. Okay, my final last change I want to make is that we hard-coded the width of each bar to 30. I'd like for that to be a variable. So either above or below t is equal to turtle, add width is equal to 30, and then find the 2 or 3 places where we use 30 and replace it with the word width. Here's a place where we used width. Here's a place where we used width. And here's a place where we used width. I suppose we can make a Dropbox with this too. What do you say? You want to turn this in and get credit for it?
Yep.
So upload the barcode chart into folder J. And then take note that there's a homework assignment that's due next week.